Hello, I'm Juliane Dickel. I'm head of nuclear energy and policy at Friends of the Earth Germany. And I would like to talk a bit about parallels and differences between Fukushima and Chernobyl. To make it clear, it's no comparison. You cannot objectively compare the two incidents. To be honest, I am no contemporary witness of Chernobyl catastrophe. I was born 2 years later. However, one of my first memories is a children's book. It's about the child Katja, her cat Kotja, and the so-called artificial sun, which forced the child to leave her cat behind at Gomel. Gomel is a city in Belarus, about 100 kilometers from Chernobyl, and Gomel city became an exclusion area in 1986, while the area around was evacuated only 5 years later. Also, it showed the highest level of contamination. So Katja was present in my childhood, and as I come from a quite nuclear critical family, I also attended some events in my younger days with liquidators from Chernobyl and Hibakusha from Hiroshima and Nagasaki, which was quite impressive in a terrifying way. During Fukushima catastrophe, I already studied Japanese language and culture at Munich University, and it made me write my master thesis about the nuclear movement in Japan after the Fukushima catastrophe. Maybe a quick look on Chernobyl and Fukushima. So Unit 4 is what we have a closer look at. It went into operation in 1978. It's located in Ukraine, so close to Belarus and Russia. It's a graphite moderated reactor, a Soviet type. It was operated by the ministry, and as we all know, the catastrophe took place in April 1986. And on the International Nuclear and Radiological Event Scale, so the INES scale, it's security level 7, which is the highest possible rate. And at the moment, the unit is under a sarcophagus to prevent radiation from spreading. Fukushima Daiichi went into operation in 1971. It's a Japan inshore, so close to the coast. It's a boiling water reactor. It's operated or was operated by TEPCO, and the catastrophe took place in March 2011. And like Fukushima, it's on the INES scale level 7. So these are the only two nuclear catastrophes with this highest possible rate. And it's still under damage control. Maybe a closer look at the causes. At Chernobyl Unit 4, actually a test ended up into a catastrophe. Engineers were conducting an operative test, which abrupt went out of control. So the output continued to rise. The emergency shutdown failed. Nuclear chain reactions took place. All that only within 44 seconds, causing 2 explosions, which tore off the reactor's roof and destroyed the reactor's core. As a consequence of the cooling water run off, the graphite rods started burning, fuel rods melt. The fire could not be stopped. It burned about 2 weeks until it was stopped on May 10th. So within a few days, around 12 trillion becquerel of radioactive particles were released into the atmosphere. That's about 200 times greater than the Nagasaki and Hiroshima bombs together. In Fukushima, it was a bit different. It was a natural disaster which caused the catastrophe. An earthquake took place, causing a tsunami, and many people died from that natural disaster or were displaced. And it also affected several power plants. Most of them shut down automatically. However, At Fukushima Daiichi, the power supply was interrupted and also the emergency generator did not work. Therefore, the cooling system did not operate anymore. The core melted down in the units 1, 2, and 3. To reduce the pressure within the NPP, so nuclear power plant NPP, operator TEPCO decided to release steam, but at the same time, of course, released radioactive particles within the atmosphere. And in addition, a lot of contaminated cooling water reached the groundwater. To be honest, Japan is used to earthquakes and therefore had emergency schedules. However, this exceptional natural disaster, together with the problems of energy supply, was too much. There were 3 meltdowns and numerous explosions in the 3 units, destroying them within the first 3 days after the so-called Tohoku earthquake. Having a look at the dispersion, it's important also to have a look at the location and the type of the reactor. So the Russian reactor at Chernobyl was moderated by graphite. So it uses carbon as a neutron moderator, allowing unenriched uranium to be used as nuclear fuel. This graphite ignited and the thermal caused a strong lift of the radioactive particles. So as a result, they reached great heights. The nearby cities and countries were affected immediately, especially Belarus. And not even 2 days later, higher radiation was measured in Western Europe, and the radioactive fallout spread over the Northern Hemisphere. If you look at Fukushima in comparison, it's a boiling water reactor, which produces more local effects, as the thermic is not as fierce as with the graphite reactor. It's still horrible, but it's not as global as with the thermic development. In addition, when the Fukushima catastrophe happened, the wind was blowing towards the ocean. So Fukushima is inshore, but close to the coast, which meant that the wind was blowing the radioactive particles in the direction of the ocean. Otherwise, the situation would have been even worse, as a high amount of radioactive particles would have met domestic territories. So probably an evacuation of Tokyo would have been necessary. Regarding the immediate measurements, in Chernobyl, the evacuation was quite slow. So 3 kilometers from the reactors, radiation levels rose up to 250 times the normal background dose. However, affected inhabitants were not evacuated until 36 hours after the meltdown had begun. And until May 1st, milk and drinking water were not analyzed at all. The distribution of iodine tablets began 4 weeks after the meltdown, so far too late. And within this 30 kilometers restriction zone, inhabitants were evacuated a week after the explosion. So far too slow. The Soviet Union sent liquidators to fix the NPP. Most of them were young Red Army recruits. Hundreds of thousands of them were exposed to extremely high radiation. Many died afterwards from the nuclear exposure or suffered radiation-induced illnesses. Regarding the Fukushima catastrophe, evacuation took place faster, however, only step by step. So in the first day, within a 3 kilometer zone, people were evacuated. The next day, it was extended to 12 kilometers, but more than 1 month later, on April 22nd, the extension was finally made. So people were evacuated within a 50 kilometers area. Authorities decided not to distribute iodine tablets at all, which was later criticized by the World Health Organization. And decommission work relied and still relies on subcontractors. There are more measurements compared to Chernobyl, but there are hints that still the authorities try to not measure too much. Regarding the current situation, Chernobyl is still under, or the Unit 4 is still under the sarcophagus, and it's still a restriction zone. The nuclear power plant was shut down in 2000, the last unit, and you can still measure the radiation also in other areas. For example, in Bavaria, venison and mushroom is so much radiated that you should not eat them. In Fukushima, it's still the attempt of damage control. So the catastrophe is not over at all. Water is stored on site, which the government wants to release into the ocean. And of course, you have frequent so-called recontamination because of storms, flooding, or forest fires. We also had that discussion last year with Chernobyl when around the day of the Chernobyl anniversary, there was a huge fire in the area, and the same you have in the area of Fukushima. So fire and wind is blowing nuclear particles and increase recontamination. What you also have in Fukushima is the idea, of course, the attempt of resettlement. So the government tries to bring inhabitants back. And you have some initiatives. For example, there's Fukushima Gambaro. It means keep up Fukushima. And it's an initiative to improve the image of food coming from Fukushima. And they do not look so much on radiation, but on solidarity. And you have, of course, the Olympic Games that will also take place in the region of Fukushima to improve the image. One huge problem, and it applies for Chernobyl as well as for Fukushima, is the flow or the not flow of information. Chernobyl was operated by the state, and the state still keeps a lot of information confidential up to now. Scientific estimations assume that about the amount of radioactive inventory leaving Chernobyl varies from 2.5% up to 95%. So much is not clear, and the government would like that it remains like that. And of course, Fukushima was operated by the company TEPCO. However, in Japan, you have the so-called iron triangle. It means the strong interdependency of the interest of politics, bureaucracy, and industry in Japan. And as state and industry are working very close together, also there you have a huge lack of information. For example, at Fukushima, there are no epidemiological studies beside the screening of child thyroid glands, and epidemiological study of subcontractors is difficult due to a lack of participation of those subcontractors. The problem is due to these catastrophes, we have a huge damage or harm of people and the ecosystem. And all that shows that, of course, we need independent science and independent surveillance to make sure that the people have the information to protect themselves. And now, coming to the conclusions, which are quite clear, I think. Of course, we need a freedom of information and independent science and surveillance, because only that makes it possible that people are protected, that the ecosystem is protected. And quite clear, both catastrophes show that nuclear energy is uncontrollable and a high risk technology, and it means that we need a worldwide phase out. Thank you.